So the last gas law that we are going to consider is Dalton's law of partial pressures. And what Dalton's law of partial pressures tells us is that if we have a number of different gases in a container, then their partial pressures, the pressures that they exert, will add up together to give you a total pressure. So your total pressure, P total, equals the sum of each of the individual pressures. So P1 plus P2 plus P3, etc., etc. All right, so let me show you a visual representation of this, and then I'll show you two examples. So in this diagram here, what it shows you is that you have a container with helium in it, and it has a partial pressure of 2 atmospheres. If you have another container that has argon in it with a partial pressure of 4 atmospheres, if you combined these two containers together, right, if you added all of the gas from this container into a new container, as long as that container has the same volume, notice they're all the same size, then the total pressure in this container is simply going to be the sum of the individual partial pressures. So 2 plus 4, which gives you 6. All right? And the only reason why we can make this assumption is because we're assuming that the gas molecules are not attracted to each other. So their partial pressures simply add up to give you a total pressure. All right? So let's look at a couple of examples. It says air contains oxygen, nitrogen, and carbon dioxide, in addition to some trace amounts of other gases. If the partial pressures of nitrogen, carbon dioxide, oxygen, and other gases are, so it gives you each of the partial pressures, 79.10, this, and this, respectively, what is the total pressure? So remember, as Dalton's law of partial pressure tells us, the total pressure here is going to be equal to the partial pressure of nitrogen, N2, plus the partial pressure of carbon dioxide, plus the partial pressure of oxygen, plus the partial pressure of any other gases. All right, so all I have to do to find the total pressure now is add them up. So 79.10 kilopascals plus 0.040 kilopascals plus 21.22 kilopascals plus 0.94. So what I get for my total pressure here is 101.3. Now keep in mind, because I'm adding, I need to be rounding based on the fewest number of decimal places. And since all of these values, so this has 2, this has 1, 2, 3, 1, 2, 1, 2, so I need to have 2 decimal places, so 101.30, and my units are kilopascals. And that's all there is to it. Let's look at one more example. Blast furnaces give off many unpleasant and unhealthy gases if the total air pressure, so this is my P total, is 0.99 atmospheres, that's my P total. The partial pressure of carbon dioxide is 0.05, that's carbon dioxide's partial pressure, and the partial pressure of hydrogen sulfide, is 0.02. What is the partial pressure of the remaining air? So remember, P total is going to be equal to the partial pressure of carbon dioxide plus the partial pressure of hydrogen sulfide plus the partial pressure, I'm just going to write the remaining air. Okay? So since I know that the total pressure is 0.99 atmospheres, and I know that the partial pressure of carbon dioxide is 0.05, and the partial pressure of hydrogen sulfide is 0.02, I can solve for the remaining partial pressure of the remaining air. So 0.99 equals 0.07 plus P remaining. So I'm going to subtract 0.07, subtract 0.07. Okay, so my partial pressure of my remaining air equals 0.92. Okay, and my units here were in atmospheres, so my units for my partial pressure will be in atmospheres. And that's it.